Hello, I'm Dr. Levon Hayrapetyan, a business professor at Houston Christian University. In this video tutorial, I will demonstrate how to sketch graphs of exponential and logarithmic functions in Microsoft Excel. A commonly used method of sketching graphs of functions is to select several values for x, then calculate the corresponding values of y, plot those points, and connect them with a smooth line. That's exactly what we will do now using Excel. So let's start, and we will start with the exponential function. As you know, an exponential function has the following general form: y equals to b raised to the x, where b is called the base and x is called the exponent. B should be more than 0 and b cannot be 1. In order to sketch, first we have to select some values for x. So I'm going to select values for x from 4. Actually, let's start from -4 till +4 with step of 0.2 or interval 0.2, which means the next number will be -3.8, the next one will be -3.6, and so on. So in order to generate the rest, instead of entering all these numbers manually one by one, Excel has this nice feature when I can select these two, and Excel will figure out the relationship between these two, and when I drag down, which means copy down, then it will use that relationship to generate new numbers. And that's what we did. And as you can see, each next number is 0.2 more than the previous one. Each next number is 0.2 more than the previous one. And my values of x is from -4 till +4. Now let's calculate the corresponding values of y, which means basically I need to implement this formula, simple formula, b to the x in Excel. So this is the cell which I designated for b. Currently I selected the value of 2, which means when I create the graph, it will be the graph of y equals to 2 to the x. This times x, which is the value in this cell, this actually raised to the x. So E4, which is the value of b raised to x. This symbol, like caret symbol, this is the means the raised to the power. And you can get this symbol by Shift 6. So I got the value for the first one when the x is -4. Now, in order to generate values for the rest, I will use another Excel feature called absolute addresses or absolute references. So the idea is that for all x's, I have to use the same b. Therefore, the b, I will make this reference to b, or this cell E2, E3 absolute, which means this one. I will make this absolute. And now I am ready to drag this down and copy all these numbers. Excuse me. Now, excuse me. Now I have the values of x's and corresponding values of y. I'm ready to plot the graph. In order to do that, I will select this entire range of x's and y's, and then I'll go to Insert tab, and in the charts group, I will select Scatter. And among scatters, I will select scatter, connect it with smooth line. So this is the graph of the function b to the x and The value of b is currently 2. Now, if I change this to 3, just look at the y scale in the y-axis. This scale will be changed. Now, if I make it 3, now this is how the graph looks like. It goes up much sharper way. So back to 2. This is the exponential function. What are the properties of this function? Even by looking at the graph, we can see that the domain of this function is the set of all real numbers. And the range of the function is the set of all non-negative numbers. One thing we can notice is if I select other values more than 1, like 3 or 4, as you can see, the shape of graph looks similar in terms of that it's increasing. The graph, the function is increasing on the entire real number set. What if I use a number between 0 and 1, for example, 0.5? Look how the graph was changed. This is when b is 2, it's increasing because b is more than 1. When b is 0.5, it's decreasing. So this is another property that when the base is more than 1, then the graph of the function is increasing on its entire domain. When the value of b is between 0 and 1, then the graph of the function is decreasing on the entire domain. So this is the essence of exponential function. Now let's switch to logarithmic function. I will switch to another tab. And logarithmic function, as you know, this is the form of logarithmic function. The function we use this log log with base is b of x. And these are the conditions. The base should be positive. It cannot be 1. And the x should be always a positive number. So the only here it should be b. The only parameter which we can play with here is the base b. So initially I start with 2. Later we will do with other numbers. So let's select some numbers. In this time I will start with 0.2 till 10 with the step of 0.2, which means each next value I will select to be 0.2 more than the previous one, which means next will be 0.4, next will be 0.6, and so on. I will use the same technique, select 2 of them, and drag down, which means copy down, and I selected the values for x from 0.2 till 10 with the interval of 0.2. Now let's calculate the value of y using this formula, where the value of b will be selected from this cell. Currently it's 2. So it will be, we will use Excel's log function, log, and then we will specify log the value of x first, which will be this value, comma, and the base will be the second, which is this. So we got this number. Now I need to calculate the value of y for all other x's as well. In order to do that, I have to make sure that when I copy down, the value of x will be picked correctly, but the value of b should be always the same. That's why the value of b, which is in E3, as you can see, I will make this absolute. Again, if you are not familiar with this technique using absolute versus relative addresses, that's fine. Just follow me how I generate those numbers, and then you can later, if you are interested, you can check Google, or you can check, there are lots of YouTube videos about absolute and relative addresses in Excel. Well, now I'm ready to copy down. And all values of y are also calculated. Now it's time to plot the graph, or I will select this entire range of x's and y's. Then I'll go to Insert, and in the chart group, I will select Scatter Chart, and as a subgroup, I will select this one, Connect it with Smooth Point. So this is the graph of logarithmic function with base 2. And what we can see, the properties which we can see here is that the domain of the logarithmic function is the set of all positive numbers, positive real numbers. And that's what's marked in here as well. That's domain. The range, which is the possible values of this function, is the set of all real numbers. Also, we can notice that when the base is more than 1, like in this case it's 2, and the function is increasing on its entire domain. If I make it 3, again, it will increase on its entire domain. But let's see what happens if I make it 0.5. Now, 2, 1, 2, increasing 0.5, which is decreasing. So when the value of b, which is the base, is between 0 and 1, then the logarithmic function decreases on its entire domain. So we saw how we can create or sketch the graph of logarithmic and exponential functions in general case. There is one important function which exponential function which called the exponential function with base e, or base of the natural logarithm. In order to create a graph of exponential function where b should be equals to e, and in order to generate e in Excel, we will use x function which calculates the e to the whichever power we put in here. And since I used 1, that means it will calculate e to the 1, which means just the value of e, which should be 2.7 something. So this is the graph of exponential function with base e. The same way here, we can create a graph of logarithmic function with base e, which is called natural logarithm. So here I'll use equals x1, which means as a base I want to use the value of e raised to the 1, which means basically e. And so this is the graph of a logarithmic function with the natural logarithmic base. So, in summary, we learned how we can create graphs of exponential and logarithmic functions, and we saw we can see the properties of these two functions using their graphs as well. This concludes my short video. Have a nice day.